So till now, 2 days of our workshop is completed. Especially in the day one, we discussed about generative AI. Okay, what types of APIs are used? What exactly the generative AI and difference between normal AI and generative AI? Such kind of basic things we discussed. In day two, the prerequisite for that generative AI. So how exactly the machine learning will work? What is the machine learning? And what you are going to train, how brainless mathematical model will get trained. So what exactly the meaning of model as a predictive equation. So the style of machine learning model lens, especially if you observe this one, straight away I will show you yesterday's picture. If you look into this picture, left side one layer is there, this is about input variables and bias. And right side, output variable. As per machine learning terminology, the input variables are called what? These input variables are called what?
Futures, right?
Yes, features. Output variable, the values of
Target.
output variable. There is special name, label.
Label.
Okay. So we train the model with help of data. The data contains two things: features, labels. The left side we kept features along with bias. The right side, label. Okay. So, and we took one example of yesterday to understand this one. Age, weight, height are input variables. Cholesterol is target variable. Okay. Each variable has its own impacting force, impacting power on the target variable. So these things are called slopes. Okay. So one hidden force will be there, that is called bias. So we named that bias as W0, slope of age as W1, slope of weight as W2, slope of height as W3. So what is the style of machine learning model lens? First, it will initiate random weights. With random weights, then it applies prediction. After that, it calculates error at prediction. So in the initial, suppose as per this example, I got 190 as error. To next time, to reduce that error, it applies a derivative. Okay, the derivative produces adjustables. These adjustables are called delta. After that, this delta we are adding to previous weights. Okay, now new weights will be produced again with the help of new weights. Again, you are applying prediction. Again, in this moment, if you calculate the error, the current error will be definitely less than to the previous error. But still error existed. To reduce that error, again it is applying derivative. Later it is adjusting the weights. So in this way, this loop keep on continue. That means as loop is continuing, error is keep decreasing. At the same time, the weight matrix is maturizing. That means knowledge. If you treat this weight matrix as a knowledge of the model, the knowledge is keep on improving. Got it. So when training will be completed in this way? After how many iterations the training will be completed?
Current error equal to
Yes, current error equal to previous error. Then you can treat that training part is completed. That means you cannot determine or you cannot fix 1,000 iterations should be done or 10,000 iterations should be done. You cannot fix it. Okay, it may happen at 100 iterations or it may happen at 1,000 iterations. So for you, the indication the training is completed is current error, previous error, both are equal, then training part will be completed. Okay. So finally, after completion of the training, the last iteration weight matrix he will take. He will deploy into the application. Got it. So before coming to the types of machine learning, here I do one thing. Whenever current error and previous error both are equal or close together or deadly close together, the training of the model is completed. Okay. After that, we test the accuracy. The practical part, you will be seeing how to test the accuracy. Accuracy of the model. If accuracy is satisfied, the knowledge of the model will be deployed into production application. That means weight. Knowledge means here weight matrix. Into production application. Then this application behaves like a human. Okay. I mean, predict like human. Okay. That means the application which contains this weight matrix, the knowledge weight matrix, that is called AI application. Now, based on this explanation, especially this current information, ML and AI, you can say ML versus AI. What is that? According to your understanding, please. Yesterday, I have seen completely ML, the style of ML, how it trains a model. Today, I'm talking a new word called AI. Now, my question is, what is the difference between ML and AI? Simple answer. ML, it trains model. AI
Learn itself.
is an application which contains trained models knowledge. So generally, in general terms, for a layman, what is AI means we call it as is automated computing program for a specific task. But technically, if you want to talk about this AI is an application. That application has a knowledge. How that knowledge is built? That knowledge is built based on the ML. By using ML, we train a model. Once all iterations, the trained iterations are completed, final iteration weight matrix is treated as knowledge. The knowledge will deploy into the application. Next onwards, that application will consume that knowledge. Based on that knowledge, next onwards, if you pass any patient age, weight, height, automatically application itself will predict his cholesterol. No need to involve the human here. Got it? All of you understood about this difference, ML and AI.
Yes, Bharat.
Okay.
Can you explain at the same time what about that DL also?
DL. After completion of machine learning types, we will come to that DL concept. Okay.
No, that differentiation it will means it will be good.
It's ML and DL.
Yeah.
ML and
No,
DL.
basic of DL. What does DL means? For ML, it means it trains a model.
Yeah,
So
DL
AI
also
means the
does.
applications
DL
have that.
also does same thing. DL also does same thing. Generally, in a neural network, first of all, okay, very brief I give you. Let's talk about this ML first. Consider yesterday example only. We have age, weight, height, and one bias, one target variable. Between them, weight matrix.
At the same time, how many types of we can segregate as a whale training? Because yesterday we see a single thing like a gradient, right?
Yes, there
I
are
mean, it is algorithm, right?
different algorithms are there. Okay, different algorithms. Gradient, stochastic gradient.
Okay.
In this way, many algorithms are available. Gradient boost, many machine learning models are there. Okay, let's consider this weight matrix, sir. What is the size as per yesterday exam? This is the story. First one bias, age, weight, height, and one target variable, which is a cholesterol. What is the size of the weight matrix? 4 by 1. Okay. So
Okay.
after that, extension to the machine learning, there is another concept called neural network.
Neural
In case of
network.
neural networks, the style is like this. Observe this. Same bias, age, weight, height. Here one hidden layer we are involving. This is just basic guideline. If I have 4 input variables in the hidden layer, I'm keeping 6. Just 4 plus 2. I kept like
Okay.
this. And one target. Now tell me, how many weight matrices? How many layers here in the machine learning? In the machine learning basic, how many layers? One input layer, one output layer, right? There are 2
Yeah.
layers. But in the neural networks, how many layers?
3.
3 layers. That means, how is the communication? The bias will hit all these things,
Each and everything, right?
right?
And that day I thought about that chat GPT, right? It works on neural
Mm,
network.
Yes, no,
Similar.
not neural network. It works based on the deep neural networks, which is called deep learning. In this way, the hitting style is like this. How many weight matrices between first and second?
It will be
Hmm, Let's say W1. What is the size? 4
1, 2,
rows,
3, cross 6,
6 columns. 4 into 6, how many? 24. So here, how many parameters?
4.
Only 4 parameters. Here, how many parameters? How many weights between first and second? 24, right? Again, look into the second and third. This will hit this. Again, this will hit this. The hitting style is like this. That means between second and third layer, again, there is another weight matrix, which is weight 2. How many weights here?
It will be
6
6
by
cross
1.
1.
How many weights?
6 cross 1.
6, comma, 6 by 1. That means 6 rows, 1 column. Total how many weights? Between 1 and 2? Between 1 and 2, 24 weights. Between 2
That
and
will
3,
be 24
6
and it will
weights.
be 6,
Total
30.
how many weights?
30.
30 weights. Okay. So this is neural network style. Come to one more thing. 1, 2, 3, 4. Input layer. Hidden layer number 1. Here 6. One more hidden layer I want to introduce. Let me keep 8 here. 5, 6, 7, 8. And one more hidden layer I will keep. Just observe this. One output layer finally. Sorry.
Uh,
Hmm.
so the processing also it will get the delay or
Delay doesn't matter, man. Finally, how well you are learning, that is important. How well the model is going to learn, that is important, not a delay. It's a deep learning. What is the difference between neural network and deep learning based on this picture?
we have one more hidden layer.
That means in the neural network, you have only one hidden layer.
Yeah.
But in the deep
Here we have
learning, more than one hidden layer will be there. Based on this, how many weight matrices here? First, you tell me in the deep learning picture, especially in the third picture, how many layers? 5 layers, right? Because of 5
Yes.
layers, how many weight matrices? Between 1 and 2, 1 weight matrix.
Yes.
Between 2 and 3, 1 more weight matrix. Between 3 and 4, weight matrix number 3. Between 3 and 4,
Next one.
between 4 and 5, 1 weight matrix. W4. How many weights here?
24.
4 into 6. That means 24, right? Here, for the weight to how many weights? 6 into 8.
8.
48.
48. Between third and fourth,
48.
8 by 6, 48. Here, between 4 and 5,
6.
6 by 1, 6. What is the total? 96 weights, huh? So this is up to 96, 96 plus 30. 96 plus 30 means 126 weights. Here, how many weights we got in the machine learning? For the same task, we got 4 weights. In the neural network,
30.
30 weights. In the deep learning,
126.
126 weights. Okay, that means where is more knowledge? Where
Okay.
is more knowledge? At deep learning. Got it? For
Yes.
example, here I got accuracy for as a specific task. Here I got accuracy of 85%. That means out of 100 predictions, 85 predictions are successful. Definitely in the neural network, I will get 90 or 92. Here I will get the accuracy like 99% accuracy I can achieve. Okay. So
Okay.
this is what, where more parameters are there, where more parameters are getting trained, the model will behave more accurately. Got it. But the industry guideline here, what is the guideline of industry is? For example, yesterday is example, based on age, weight, and height, I want to do prediction of cholesterol. This kind of simple things can be done with machine learning. Got it? For example, you are attending my voice, you are listening my voice. My voice is a male voice or female voice?
Male.
Male voice. Immediately, but just my voice is input to you. Okay, think that your brain is a trained model. You immediately your brain is predicting whether it is a male or female voice. Okay, this is what some little complex. Such kind of things you can do the prediction by using neural networks. Okay, that means if complexity is increasing, you will be going into neural network. Okay, more complexity has increased in the data. So you want to construct a relationship between features and labels. At that time, you have to use deep learning. A simple example, sir. Let me come to this one. Or some pics I will demonstrate you. I will show you. You tell me. Male and female images. Just look into this picture. Especially this picture. Only eyes part is there, head part is there. Okay, there is a forehead, there is a nose, there is eyes. Especially among these two pictures, which is male, which is female, sir?
To your left, male, sir. To your right, female.
That means first one is male, second one is female. But you did not see complete. But how your brain could able to say that? How your brain could able to say that? Who is male, who is female? Come on, quick interaction, please.
In hairstyle.
Nothing. You did not do any
Our brain has
measurements.
trained.
You did not
Based
do.
on past data.
Yes, based on the patterns. Already your brain got trained about male patterns and female patterns. Right? That's why not only you, even kid able to say the answer for it. Understand? So this is called like a simple prediction. If you talk about simple prediction, there are more distinctive features. Between male features and female features. That means between two classifiers, you can say if you treat male as one classifier and female as one classifier, more distinctive features between classifiers. Again, come back to this picture. So look into this picture, sir. Look into this picture, which is art. Who is male and who is female? Blue or red? This is
Blue
blue.
is male, red is female, sir.
That's it. How you could able to say? Even you did not see eye, you did not see nose, you did not see any physical part. But how you are able to say? Because already you know the basic structured features. Okay. And the basic dressing features also. Even especially the left side picture also you are able to say that one. Who is female, who is male. The first one is female, second one is a male. Even this is left side, some of face is about male and right side, some of face is about female. So how all these things are possible? Because there are more distinctive features. Okay, especially observe this one. I'm taking a picture as a simple drawing. Think that this is a circle. This circle is a set of male features. This is second circle. This circle is a set of female features. It's a male features and second one is a female features. There are common features also, but common features are less, very less common features. I'm not talking about biology. I'm talking about features, facial features. Got it. But more male has some more distinctive features. Female has more distinctive features. That means here some 90% extra features has his own unique features. Here some other 90% of female unique features. Of course, there are some commonality, which is 10%. Okay. So in such cases, you can use machine learning. That means 2 layers training is okay. Okay, one input layer, one output layer between them, weight matrix. So here, this kind of prediction simply called as simple prediction. What do you mean by simple prediction means? Less common features, more distinctive features. Less common features and more distinctive features. Okay, now I will show you another picture. Just to try, are you able to say the answer or not? Come on, sir. These are the rabbits. All of you look into this rabbit. Male rabbit or female rabbit? Answer me, sir. This is a male rabbit or
I
female?
can't say.
You cannot say. Correct? Why? So look at here. There are 3 rabbits. You cannot say just by seeing the rabbit pics or rabbit live. You cannot say which is male rabbit, which is female rabbit. But male rabbit is recognizing female rabbit or not? Female rabbit is recognizing male rabbit or not? What's the problem here? Why your brain not able to say that? What might be the reason?
We can't see much distinguished features.
Yes. Okay, if you treat this as 2 rabbits are here. Think that one circle is for male rabbit features. And second circle is about female rabbit features. So here in this case, some 99% commonality is there. Only 1% is distinctive feature. Only 1% is distinctive feature. 99% both are similar. 99% common features are there. That's why both seems to be the same. Your human brain could not able to recognize it just by seeing the pic. So this is called complex prediction. Okay, this is called complex prediction. So what is the comment on the complex prediction? More common features and very less distinctive features. Very less distinctive features. If it is the case, we have to go with deep learning. Got it. So the guideline for this. So how to find the commonality? Again, that is one technique here. So later we will be learning like about those commonality techniques. If commonality is up to 25%, you can proceed with ML. If commonality is up to, that means 25 to up to 60, you can proceed with the neural network. That means 3 layers. One input layer, one hidden layer, one output layer. If commonality is greater than 60, that means 62 up to 99 point something. Like this. Then you have to proceed with deep learning. On that way, you can choose it. Okay, how to choose one particular for a particular scenario, which type of technique whether you will use. Okay, that depends on the commonality. You can take the decision. So how to find the commonality? That is another technique again. So got clarity. So when to use what? Very, very less commonality. Proceed with machine learning. Some mid-range commonality. Proceed with neural network. Okay, more commonality, like in the rabbit pictures we have seen that 99% common features for appearance. So in that case, basic machine learning neural network won't give you accuracy. At the time you have to train the model more deeply. That's why you have to use deep learning. Finally, this deep learning will acquire more knowledge about the data. Got it. So finally, for a deep learning, there is a statement. Observe these statements. Recognize a black cat in dark night. Such kind of tricks deep learning can. Please comment the challenge in that task. Recognize a black cat in dark night. What's the problem?
Can't see, sir.
You can't see, but you have a clue. You have a small clue for that. Recognize a black cat in dark night. You have a small clue, that is a spark of eyes of the cat. Got it. So such kind of complex predictions also can be done with deep learning. Got it? So this is simply, so how you are training in the same style as machine learning. But in the machine learning, you find only 2 layers. But in deep learning neural network, more than 2 layers will be there. Got it? So simply I add one statement here. ML, 2 layers. Input layer, output layer. In the neural networks, 3 layers will be there. Number 1, input layer, as usual. Always first one should be input layer. Second, hidden layer. Third, output layer. In the deep learning, more than 3 layers. As usual, 1 input layer. And second, more than one hidden layer. In neural network, only one hidden layer, here more than one hidden layer. Maybe two, maybe three, maybe four. But how to choose how many number of layers? That is another different technique. Later in coming concepts, I will be explaining. And output layer. Like this, right? So you take anything, any discipline, whether ML or neural network or deep learning. All these are actually sub-disciplines of machine learning. But nowadays they are considered as a separate departments. Okay. So you take anything, the types of machine learnings you can understand, like supervised learning, unsupervised learning, reinforcement learning. All these three things, three types of learnings are available in ML, NN, and also DL. So simply those are called types of machine learning. You can say them as machine learning approaches. These are basically supervised learning.
Bharat, one more thing.
Yes.
In a deep in DL, we have three things. Like for a simple, we use a simple prediction, and for second one, neural network, it will be, can I say it as a complex? And what for DL?
Deep learning more complex.
More complex.
More complex prediction. Especially consider the example of rabbit. Consider the example of dark cat in darknet.
Okay.
More complex. Okay.
Thank
Yeah,
you.
like that. So come to the machine learning approaches: supervised, unsupervised, and reinforcement learning. In this way, there are three approaches. In supervised learning, we train model. In unsupervised learning, here also we train model, but purpose different. And in reinforcement learning, we train agent. So this is important. Based on this reinforcement learning and deep learning combination, all generative AI models are built. In the initial beginning, what are the things we discussed, like OpenAI, Llama, LangChain, such kind of all the things, all those are the APIs of trained models. Okay, those are built based on the combination of this deep learning and this reinforcement learning. Okay. So first of all, what is supervised, unsupervised reinforcement? We need to understand. Going to talk about this supervised learning.
Based on label data.
Yes. In the supervised learning, data contains two things. What are those? Same yesterday example only. Yesterday example actually comes from supervised learning. What are those? Data contains two things. Number one,
Features and
features. Number two,
labels.
labels. Got it. So with the help of features and labels, if you train a model, that approach is called supervised. Understand? That means finally, what is goal of model? What is the goal of model? Understands relationship between features and in the form of weights. The weight matrix is the knowledge of the model. The weight matrix is the knowledge of model. Understand this point, sir? Okay. And come to this, the second. I'm going to talk about unsupervised learning. Here, data contains only features. that means not labels. All predictive models comes under supervised. That means a model which is doing some prediction, that is called predictive model. All predictive models. Comes under this supervised. Example, gradient descent algorithm or decision tree, random forest regressor, linear regression, non-linear regression, lasso regression. In this way, many models are. Okay. All these models are doing some prediction. Got it. But in unsupervised learning, the data does not contain label. It contains only the features. Okay. So here, all clustering algorithms or clustering models comes under unsupervised learning. Okay. Example, K means, K median. Such kind of clustering models are there. What is the importance of a clustering model? That's one simple example. I'm taking something here. It's a simple graph like age and income. So bank has some data of loan applicants. I think that all these are the loan applicants. Okay. Are already 1 year back who took loan and who paid some payments. Okay. Loan customers. Okay, now bank has plotted something. This is first person plot. He is plotted over here. That means he has less age, less income. Some people nearby to this one. At the same time, there is some other group, even though age is less, but their income is high. Of course, here in this example, I am considering only two variables. One is age, another one is income. But both are here. Both I am treating as inputs only. There is no other target. And there is another group here. Their age is middle. Their income is also at middle level. Some mid range of income. At the same time, there are some other people. Their age is very bigger, but income is very less. On that way here. At the same time, there is another group, age is bigger, but at the same time, their income is also bigger. Think that totally 1,000 customers are there for your bank. Let's say your bank is ICICI. This is already customers who already took the loan, and they are paying to the bank. Total 1,000 customers I have. If you look into this picture, how many behaviors are there, you can understand. How many behaviors are there, you can understand. There are 5 behaviors. I want to give a label to them. I want to give a label, that means one title to each behavior. What titles you can give? If it is first, you can treat that behavior as a cluster here, technically. A cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. Okay. So look into this center cluster. So what title you can give? Middle age, middle income. Okay. Look into this one, top right side. Big age, that means high age, high income. And look into the top left, less age, but high income. Last, left bottom, less age, less income. On that way, for each behavior, you can group it. This kind of a behavioral classification will be done with clustering algorithms. What additionally this clustering algorithm does is, it finds a central behavior for each cluster. It finds a central behavior. That central behavior is called centroid technically. Observe that centroid I am marking with red mark. This is centroid for this cluster. This is centroid for this cluster. And this is centroid for this cluster. And this is centroid for this cluster. 5 behaviors, that means 5 clusters. For each cluster, that algorithm will calculate centroid. Okay. So how to calculate all these things? In practical part, we will be learning. Just this is overview. Okay. Now this is the story. Your K-means algorithm classified our data. Now that means it divided your data into 5 behaviors, into 5 clusters. After that, it calculated a centroid for each cluster. Got it. So let's say this, look into this cluster. What banker identified is, in this cluster, there are 350 people or 300 people. Out of 300 people, 260 people paid loan. Well, remaining 40 people did not pay the loan well. Very irregularly they are paying. Okay. In the same style, look into the first cluster. There are 200 people. Among 200 people, 180 people did not pay. Only 20 people, they paid loan. Okay. So this is what, based on their history, the banker has identified it. So here some 300 people. So out of this 300 or 100 people, out of 100, 90 people paid well. And remaining 10, not. Here again, 200. Here 180 paid. 20 not paid. Here 100 or 200. Here the thing is 120 not paid. 80. They paid loans well. According to the history, banker has identified. Now banker wants to apply a label for each behavior. Please recommend me the labels. What label you want to give this for the top left? Out of 300, 260 people paid well, 40. Okay. So it's a group of called no risk, because majority of the people are paying loan well. So here, what about this center group? 90% of the people are paying well. That means no risk. So here, 90% here also paying in the top right. The label for this, no risk. Look into this bottom right.
High risk.
Yes, risk. Okay. So here, this is high risk. 90% did not pay. Got it. Here 60% did not pay. That's why simply you are calling it as a risk. Here, high risk. Understand? After that, okay, these centroids have been deployed. These centroids have been deployed into the application. Next onwards, this is me. I am a loan applicant. Okay, I am a loan applicant. My name is Bharat Sridhar. My age is 46. And my income is, let's say, 30,000. That means for which behavior I will match? I have 5 behaviors here, 5 cluster here. Which behavior I have? A is bigger, at the same time, income less. That means look into the last group, bottom right. Okay. So how it knows, how your model knows is, it will calculate the distance. It will calculate the distance between each centroid. The distance between my attributes and centroid. A simple mathematical formula, what you have learned in your 8th class mathematics and 9th class mathematics in the geometry mathematics, you have learned square root of x1 minus x2 whole square plus y1 minus y2 whole square. By applying such kind of formula, with my age and income, it will calculate the distance between each centroid of each cluster. For example, here the distance, let's say 10 units. It's a distance here, 50 units. And here is the distance, 80 units. Here the distance, 70 units. Based on this distance, okay, here also like the distance, 25 units. To which cluster I am closer? I calculated a distance between my attribute and centroid attributes. To which cluster I am nearby? By seeing the measurements. Sir, please reply fast. Here 50, 70, 25, 80, 10. Which is less value? Which is less value here? 10
50,
is less value. 10 is the distance for this cluster, right bottom. That means my behavior is close to this risk behavior. Got it? Now what application is saying? If they sanction loan to me, they will be kept into the risk. So bank, that application will automatically reject my loan request. Got it? So here there is no input where there are only input variables. Age is input, income is input. I'm not going to predict income. Here input is age, at the same time income. Both the things I am passing. Got it? So my attributes are matching to which behavior I am going to find out by using the help of distance between my attributes and those centroids. Got it? So my behavior is very close to this risk cluster. That's why that application will reject. For example, there is another customer. Her name is Lata. Age is 25, but income is 2 lakhs. If they calculate the distance, Lata behavior is deadly close to this cluster. Okay. So what is the label for this cluster? No risk. Because of no risk, that application will sanction the loan to Lata. Understand? On such a way, the bankers can use this one. Got it? So this is what unsupervised learning. Look into this unsupervised learning. Data contains only features, but not labels. Got it? So what are the clustering algorithms? We have like k-means, k-median, still other clustering algorithms also there. One by one, I will list later. Okay, these models comes under unsupervised learning. Finally, what model lens? In supervised, what model lens? Model lens, relationship between features and models. Sorry, relationship between features and small change. Labels. Here in unsupervised learning, model lens, behaviors, behavior clusters in data. Here every variable is input variable. There is no target variable. So that kind of things are called unsupervised. Right? There is a third thing. So for this a little discussion, a more elaborated discussion, because this is the main heart of your generative AI. That third approach in the machine learning is reinforcement learning.
Agent will take.
Pardon?
Agent.
Here agent will be tried. So on unsupervised we have a model. In supervisor also you have. But here in supervised model lens, relationships between features and labels. In unsupervised model lens, behavioral clusters. Okay, that means central behaviors it is identified. And in the reinforcement learning, a different technology we will use, like tomorrow entire session, just I will list them. To understand about the reinforcement learning, there is no data. Okay, then what will be there? Environment will be there. Environment rules. Okay, there is no data, only environment rules will be there. And here, who will be the learner? Agent is the learner. Agent performs actions in the end. Every action can be a right action, action can be a wrong action. For every action, environment returns rewards. Okay, environment returns rewards. Reward can be positive reward, it can be negative reward. A small examples are in a traffic signal. At a traffic signal, what are the rules? Red light. If red light is on, you have to stop. If green light is on, you have to move. Understand? If a walker symbol on, the persons who are walking or who are crossing the road, they can walk. On the way, that environment has some rules. Suppose if red light is on, you did not stop the bike, still you keep on moving, that is what your action. But immediately the police, the constable will apply a reward to you. The reward can be a positive, reward can be a negative. For right action, positive rewards. For bad actions, negative rewards they will give you. Maybe penalty or maybe arrest, whatever it may be. Got it. Immediately based on the reward what you received, always you keep on trying to improvise the reward, Understand? So this is what that agent learning style. Got it. That means here always agent goal is try to improve rewards. Got it. So how this reinforcement learning model is going to get trained and all these things, and tomorrow completely we will understand. This is just a basic terminology within the reinforcement learning. Understand? So here again, the special algorithms, all these things will be there. So no need to learn entire coding for this. How exactly the reinforcement learning works, once if you know, then straight away you can step into generative AI. So what exactly the reinforcement and what is agent, what are actions and rewards, and how finally your agent will learn from the environmental rules based on the rewards it received. So completely that part learning tomorrow you will see. So as per today's knowledge, please summarize this today's session. What are the key points here? Especially in the as part of the day 3. What is AI? Please tell me. What is AI?
Trained models.
Don't say
Application
generic. Don't say generic definition. Don't say generic definition. If an application is deployed with trained models knowledge, then that application is called AI application. Got it. But how to train the model? By using the machine learning or neural network or deep learning. Finally, trained model, once accuracy got tested, if you satisfy with that accuracy, then you will deploy that model's knowledge into the application. Model and model's knowledge, both you will deploy. Then your application, that application behaves like human. Got it. That means you want to build a application, means the backend heart, the backend brain is the training of the models. The training of the models can be done with machine learning, neural networks, deep learning. So what is the difference between machine learning and deep learning and neural network? In machine learning, I have 2 layers. Input layer, of course, that is called feature matrix. Output layer. Between input layer and output layer, one weight matrix. That weight matrix is knowledge. But in neural network, I have 3 layers, one input, one hidden, one output. Totally 3 layers means how many weight matrices? 2 weight matrices. 2 weight matrices. But in deep learning, more than 3 layers. In deep learning, more than 3 layers. That means one input, in the last one output, but between them, more than one hidden layer will be. Hidden 1, hidden 2, hidden 3. In this way, number of hiddens you can increase, you can decrease. But how many layers that you can choose? A little more knowledge is required. After a few classes, you can understand that. Okay, come to the types of machine learning. Basically 3 approaches: supervised, unsupervised, reinforcement. In supervised, you will train the model. In unsupervised, you will train the model. But what is the difference? Please tell me what is the difference between supervised and unsupervised?
Label main differences.
Works on label data and
Yes.
on label data.
In supervised, data contains features and labels. Okay. But in unsupervised, data contains only features, but not labels. All predictive models comes under this supervised. All clustering algorithms to find out the behavioral groups in the data, unsupervised will be used. In supervised learning, what model will learn? Model will learn the relationship between features and labels. In unsupervised, what model will learn? Model will learn the centroids of behavioral groups. Here, what is the knowledge of the model? Weights. Here, what is the knowledge of the model? These centroids. Observe the red circles. These are the centroids. Centroids are treated as knowledge of the model. You got it. But reinforcement learning completely different. In the reinforcement learning, the learner is not model, the learner is agent. And you don't have even data also. You have only environmental rules. Okay. So here a learner is agent, learner performs actions in the environment. For every action, environment returns a reward. The reward can be positive or negative. Always agent is trying to, based on the mistake or based on the action it performs, based on what reward it received, always it keep on trying to improve the reward. Okay, so tomorrow class completely we dedicated for the reinforcement learning and its behavior, right? Okay, sir.